Hello everybody, I'm Oskars from Dativa. We are recent sponsors of this event. I like this event a lot. I like what Edgars is doing. I like people joining here and sharing some ideas. Who am I? I identify myself as a software geek. I think we should be proud of being geeks. So I just wonder how many people also think of themselves like being a geek is something completely normal. I should be proud. Yeah, exactly. So some say girls run the world, but I think geeks run the world actually. So I think we should celebrate this. So anyways, I'm a geek who worked in private sector, and I still do, but after working in the Riga City Council for a while, I joined Dativa to work with solutions for that is being used in government services, and I kind of liked it a lot because this is where a lot of people are using it. I felt that this matters to people, and this is also a reason why I didn't sleep well yesterday, because we were delivering a solution that maybe some of you have used. If you have a child of 9th grader who wants to join high school in 10th grade, then we recently launched a solution who manages all the queues and attendance and management of applications. So, and this is what I like in Dativa, that we deploy and we build solutions that every citizen uses. So, and here one of the things that we have tried out and I wanted to share with you is having deployed the AI models on our own infrastructure. So I'll just share how it started and how it goes. So in 2025, when the AI hype train was already going, we were like, we have to jump on this train. So, and we started with what I think everybody who is missing the AI hype train, they should do is just create a wrapper on OpenAI API. So this is what we did for the help desk. We basically created a RAG solution where we indexed all the instructions that we have. We have somewhere around 40 different modules for municipalities that they use every day. And they have a lot of questions because those are like big systems, and so it's good that they have questions, and we want them to get faster to their replies. So we built kind of a RAG solution where they asked the question and they got an answer. But that was super simple. It was just a wrapper on OpenAI. We were just trying to learn this, and it was a nice experience. We wanted to get farther, and we understood that in order for us to fully use AI, we need to be able to trust it, and we need to be able to work with the sensitive data and the data that we would never give to a cloud. So what we did, we together with our partners, Capital, we just bought a big GPU workstation and tried to evolve and learn from building it. And I will cover today what hardware we serve there, what is deployed there, and how we observe it. And maybe you get something out from this, and maybe you will give a feedback to me so that you have something similar, or maybe we can improve how we use it today. But virtually, we bought a workstation with 96 gigabytes of VRAM. That's the major number that you actually have to look at, because that determines, of course, how big the models you can run. And the other parameters, of course, matter as well. Like you want a CPU with a lot of threads, because you have to get a big throughput of data to generate tokens. You also need a good M2 drive, because large models, if you want to offload it from the RAM you need to get it fast back to the VRAM so that it spins up in seconds, not minutes. So we didn't know how big the hardware should we get, so we bought this and just played around and to understand whether we need to buy a next one, bigger one, or a smaller one. So this is what we started with. But what currently we have is actually, we are using this for a lot of purposes. And the first and the basic one is just using like a chatbot. We deployed the LLM model there. We have a UI. We are using open source OpenWeb UI product for this. And we're just using it to like chatting with it, generating different kinds of texts, analyzing documents, etc. But as the time went by, we evolved, and I will cover this later in the presentation, that we are also using it for a code review agent. We're connecting different tools to get integrated with OpenAI compatible endpoints. We also deployed a Whisper large speech-to-text model so that we can get transcriptions of the meetings that we have without sending them anywhere in the cloud. And GitHub Copilot is just a plugin, and it allows to connect to a local workstation, so we also can do an agentic coding without using any of the cloud services. And of course, MCPs, which are like literally hands for LLM, so that we can execute and search different kinds of tools in our organization. So at this point, I would say it's more like a cornerstone of the AI kind of platform that we have in the organization. So this is like the heart of what actually serves the LLM. At the moment, we're using vLLM. I'll cover the alternatives later on. We also now use LiteLLM because without it, you can't easily monitor who is using your LLM's memory, and it's hard to diagnose who is like overbooking it. And of course, OpenWeb UI that I covered. And we're currently running a Qwen model, which for us, this is the best one. I will also cover why we use exactly this. And it doesn't take all of the VRAM, but it takes around 60 gigabytes of the 96 gigabytes. And we have a few tuning parameters there that we find that work best for us. Then a bit of a capacity. Of course, this is not a huge AI workstation, but for an organization like ours, we're able to do well. 262 token prompts are fairly large. You can even do agentic coding on this. And you can have 2 to 3 people using these big context token prompts, and then for lighter queries, of course, we can get up to 40 simultaneous users. And for us, for our usage at the moment, this is enough, but maybe it will not be in the future. And I will cover a bit how we observe it, because we didn't thought about how to observe it until we needed it. And we needed it because we wanted to diagnose when something went wrong, so when it was unresponsive. And we wanted to also see which processes uses most of the memory and loads the GPU most. And not just because so that we would kick it out, but just to understand how much resources do the code review process uses, how much process does the OpenWeb UI process uses, etc. And also, of course, to debug slow prompts. And actually, it was fairly straightforward to set it up like the basic monitoring. There were out-of-the-box Grafana dashboards that you can deploy and that connects to NVIDIA drivers. So it was very straightforward to monitor the actual GPU load, but that was not enough to diagnose further what's going on underneath. Like it gets the overall status, but not in more details. So in the second level, we had to look in the processes of GPU processes in the VRAM, although even here, like the vLLM works in a way that it loads all the model in the single process, and that's the fastest way to integrate with it. But then, of course, it takes the most of the space, and all the other custom scripts that we're using, they're just tiny users, and it doesn't give us much. But then we I think this is dashboard from vLLM itself, and this gave us a better understanding of how long does the prompt get to the first token response. And later on, when we deployed LiteLLM, and we started to use separate access tokens for each usage, and we were finally able to determine which token actually uses most of the tokens. And by the way, I was using the most because I was doing agentic coding, and this is by far the biggest load, but it pays off because I sometimes have to deal with the documents that I don't want to share with anybody, with the specifications that I don't want any cloud solution to have, and this is actually a super good feeling when you can do almost offline coding and still have an AI agent at your hand. Because once you get used to agent coding, you don't want to drop it, no matter in which project you work. So that's about the monitoring. And then we deployed a few custom components that I will also cover here. So the serving part that I mentioned, this is what serves the interaction part with the vLLM. And then we have RAG components and what we call OPIS. We call OPIS because it's RAG solution, and it kind of we actually have two solutions. One is OPIS and one is OM, and it means granny. And the name is because it tends to forget things if you talk a lot with him, even though they know a lot. So we thought this is a very appropriate name for this. And this is basically a RAG component suite. It's V8, which is a vector database. So you feed in a large chunks of documents into V8. It transforms it with transform it in vectors so that you can query it by natural language. And then we also use docling, which is extracting text from Word documents and PDFs. And we have Airflow that does it on a daily basis, so that all our internal, yet confidential, knowledge base transforms into an AI searchable RAG solution. And then we have a bunch of our own custom MCPs that connect to our internal tools, like Redmine or Dativa. We use on-prem Git platform as well. And then some supporting features like speech-to-text that I mentioned. Yeah, this is the pipeline that I described. That oh no, this is not. This is the MCP pipeline. So we're having small MCP modules connected to each data source, which we get information from, and then we're pre-processing it, sending it to vector, and then we have a RAG API that serves it. This I covered already. Yeah, then one thing that we had to solve on moving further, and this is one of my colleagues' university work. I think it's a great achievement overall. But the problem working with MCPs, so MCP is like a hand or the tool that you can give to LLM. But when we connect it to internal tools, we have to manage the access control. So we have a Redmine issue tracking system, but we don't want everybody to be able to see all of the tickets in the company. So we have to have a way to gather, to get what the user token in a secure way so that they can chat and list only the tickets that the user has. So we did our brokering component, which virtually initiates the session, does an authentication, stores the token for the session, and it rotates it periodically. But then you can work with the chatbot with your own token, with your own permission system, and it can query the Git repositories that you can access, and it can see the tickets that only you can access, etc. And this is the experience that we wanted to achieve. And then I wonder how much time do I have still?
Very interesting. Please go on.
Okay. I'll overspend the time. Okay. And then I wanted to share the lessons learned that we stepped on and learned from, so that maybe it suits you well too. So the classic RAG is a guessing game. So the classic RAG is virtually retrieving chunks of data from the vector database. And this is what we initially did. Like, we indexed all the documents, and then we queried by the prompt, and it find the relevant chunks of information that is relevant to this the question at hand. But the problem is to fine-tune the amount of information that you actually need to get from this vector database. And sometimes you ask a question like, what's the surname of your colleague? And you need a tiny piece of information to get from this RAG. And sometimes you have an overall question of, like, I don't know, how do performance evaluation works in your company, and then you need to get a lot of information, and you need to get all this into the context so that LLM can provide an answer. And this is really difficult to balance this and fine-tune. And overall, currently there's almost no reason to go with this solution, and instead it all moves to the agentic RAG. It's like when we let the LLM query your data sources and figure out and do loops, like do multiple queries until LLM figures out that, okay, now I have enough information. And this is what we really saw with our data sources too. Like, if we ask a simple question like, where does my colleague sit? We have in VP like just a map of an office, and it gets a page. It figures out, okay, this is enough information. He returns it. But if he can't find any information, sometimes it does multiple loops, like tries to modify the search, tries again, do like 10 loops, and if the information is still not there, the LLM can decide to prompt a follow-up question. And this is a good way to the correct way to behave as a chatbot. Then about the model choice, it was really like, I don't want to say this, but you have to pick your own model that suits you. Like, I hate when people say that, but this is like, I feel that this was true. But anyways, we iterated through a series of models, and we tried, we started with the GPT-oss. This was the base where we started. That it worked well, but then we moved to Gemma 3 and Llama 3, which are bigger models actually than what we are currently running. But those models have difficulties on the Latvian language first, and also when we talk about MCP, they kind of struggle on figuring out which tool to call. So over a series of models that we tried, we are on Qwen. It has surprisingly well Latvian support, and it also is good in figuring out which tool does he need to call. Like, if we speak about Redmine or tickets, he can understand that, okay, I need to query a ticketing system. And of course, it's also good for agentic coding. And the model choice matters a lot also because once we use vLLM, we can't really deploy several models at the same time, because the model is loaded in GPU all the time, and if we want to switch it, we need to unload it and unload a new one. And since we're using it for multiple purposes, we need a model that works reasonably well for all the use cases. Agentic coding for me, AI review for teams, of course chatbot, and MCP tooling. And Qwen is universal, it has good Latvian language support, and is reasonably small as well. We even tried the bigger model, which still fits in our GPU, but it was slower, and the improvement didn't felt that it's worth it. So we're still sticking to this smaller one. There's headroom in GPU for the caches, and it works fast and smooth. Yeah, and then Ollama versus vLLM. So maybe you know Ollama for running it on your laptops. This is, I think, the first go-to tool which everybody uses, and this was the first tool we used. And they are a bit different in how they treat memory. So Ollama loads a model in the memory, and it can unload it when it doesn't need it, which is good if it runs on your laptop. But for a shared box like this, it struggles with the concurrency because it loads the model. You have to wait a bit until it loads it, and then it doesn't work well under concurrent load. And vLLM, on the other hand, is built for better concurrency, but you pay the cost that it will always keep the model in the memory. And it worked much, much better in terms of concurrency, because previously we were barely able to use 1 or 2 simultaneous sessions, and now in the vLLM, if those are just sessions, like 5, 6, 7 sessions concurrently is fine. Agentic coding, maybe 2 to 3 sessions. We still use Ollama for this Whisper model because we don't need it all the time. So this is where Ollama is good. Like, it loads the Whisper module when somebody transcribes, and then it unloads it when we don't need it, and frees up the precious GPU memory. And then the real struggle is evaluating models. We started this when we built the first RAG solution, and I really wanted to have a benchmark of how good these questions come out. Like, if we ask where my colleague sits in the office, there is an answer that I can, look in the answer. And we built a series of questions like this to have a benchmark, and it worked well to compare different models on this RAG pattern. But it broke when we switched to MCP and agentic loops, because now when I ask where does my colleague sit, it sometimes does a follow-up question like, is this your colleague from Dativa? And I'm like, yeah, this is the colleague from Dativa. And he's like, yeah, Dativa has a floor plan in the wiki, so he sits there. And he asked the follow-up question, but that's the correct place, the correct behavior. But it's hard to evaluate because there was no correct answer in the first answer. And we tried some tools how to feed in series of questions and then assert the output, but we actually didn't have a good way to connect it with OpenWebUI that we use. So we tried this long views, and we were not able to set what I expected, like a series of questions and expected answers. So we're actually not having a benchmark anymore of how good our tooling is. It's very subjective. We just try some questions that we know we typically use. Of course, we use Latvian to assess the language skill, etc. And we just use our human judgment. And me as a software engineer, I don't quite buy it. Like, I would want metrics or something more tangible, but this is a shortcoming that we're struggling with. And then what was surprising is that the box that we have is actually pretty enough for the load that we have. I can understand that there might be really struggle if we would want to have a production workload on this machine, because concurrency is the difficult part. Like, when you have a lot of requests simultaneously, it can be very difficult to handle it, because this is not the orchestration platform where you can just spin up more containers. It's very limited. But for our needs, for company, it seems to work well. There are no that many peaks. unless I turn to agentic coding and start to use all of the context that I need. But overall, it served, and we don't regret the fact that we didn't pick a bigger box, and now we just bought a new box to have it next to this one. And I also wanted to share what I'm looking for in the future. It relates to what I already said about MCP and agent loops. And since we have this all on premise, we already have tools that can search our internal tooling to answer questions that we have. Like, as a joke, I typically every week I query it to ask which of my team is the best developer, and it tries to get into the ticketing system to find some tickets and evaluate, and then it says like, yeah, this guy resolved 2 tickets and he's the best one, and I'm like, yeah, you did your work, but seriously, what we want to move to is writing capabilities of these tools as well, so that we can integrate these into a workflows. Like maybe we want to assess the tickets that we have in the ticketing system by some information that he can already gather. Like he can look into our Git. So he could, if a bug is registered, he could do an autonomous fetch of the source code, and he could do a quick judgment of how difficult this bug could be, and it would help a project manager maybe before it even is given to a software developer, for instance. So the next step would be to integrate into our workflows. Yeah, and the challenge for this, of course, would be tool code reliability and the write access, because we will need to ensure that a prompt is always there and the user decision is also always there. And as I told before, the authorization problem is already solved for us. So if the tool would create a new ticket or to create action, it would be with the correct scope and with the correct user context that is already set. And then these honest setbacks or honest challenges that we have is that there is no failover for our workstation. It's by design. This is what we expected, but in the long run, maybe it will become a problem. Also, we use some duplicated tooling, like 2 different vector databases that we might also need to consolidate at some point. And as I mentioned, the evaluation is really difficult. So if any of you have a very good experience with a framework who assesses the smartness of LLM, can come talk to me afterwards. I'm really looking forward to this. And of course, tool call reliability is also not perfect. Sometimes it fails to do a simple ticketing system lookup, even though Qwen is the best at this by our tests, but it's still room for improvement. So that's it. Thank you.